We got folks coming in now. Welcome to everyone who's joining us this morning or afternoon or evening, depending on where you are. We'll be getting started soon. I'm just going to give a little bit of time for other folks to join, but we'll try to get started in about 2 or 3 minutes. We will also be recording today's webinar and sharing the slides and the recording with all the participants after the webinar ends. And if you have any questions during the webinar today, feel free to raise your hand through the Zoom function, and I'll unmute you so that you can ask your question, or you can also put your question in the chat, and we'll do our best to answer it. We'll have a Q&A session at the end of the webinar, but feel free to put questions in the chat during the presentation. Oh, thank you. Okay, so yeah, you'll have to put your questions in the Q&A. Alrighty, so I think we should go ahead and get started here. Now that we're about 5 minutes into the webinar. So I'll just say welcome again to anyone who's joined. Thank you so much for coming to the webinar today. We're going to be going over the Chameleon testbed, and specifically how you can utilize the testbed for your experiments. My name is Mark Richardson. I'm the technical project manager at Chameleon. I'm joined here by my colleague, Mark Powers, who is a software engineer and also helps operate the Chameleon testbed. And we also have Sasha Hanold, the chair for the reproducibility initiative at SC24. We're all here to help you get off on the right foot or the right direction as you begin to explore Chameleon for your SC24 experiments. So we'll be covering what Chameleon is, how you can use it. We'll explain some of the finer details about how to use it effectively. And Mark will be providing a kind of an in-depth demo. I'll be providing a brief introduction at a high level, and then I'll hand it over to Mark for the more in-depth demonstration of testbed's capabilities. As I mentioned before, we'll have a Q&A session at the end, so you'll be able to ask as many questions as you want, but feel free to put questions in the Q&A during the presentation if they come up, and we'll do our best to answer them during and after. So let's go ahead and get started. So what is Chameleon? At a high level, Chameleon is a bare metal distributed testbed. We have sites at supercomputing centers at the Argonne National Lab in TAC. The testbed is specifically designed for computer science research. It's kind of similar to the cloud computing platforms that you might be familiar with, like AWS or Azure, and that we provide IT resources to users, but Chameleon is free to use thanks to the NSF. The testbed has a huge diversity of cutting-edge, state-of-the-art hardware and a large capacity for storage, so you can run experiments with lots and lots of data. We also provide bare metal access, so when you reserve a bare metal node on Chameleon, it is completely your node. It's deeply programmable, reconfigurable, and this is really your node, so it gives you the flexibility to conduct a greater variety of experiments. And while we do pride ourselves on the bare metal access that we provide, we also offer virtual machines with the understanding that every researcher has unique experiment needs. And we also have an integrated edge computing testbed called ChiaEdge, which is directly connected to our bare metal sites, which allows you to leverage fully the edge to cloud continuum. And we also support a number of integrations, namely integration with Jupyter for easier experiment packaging. And finally, this testbed is open and collaborative. You can share your experiments on the Chameleon Trophy service, which we'll go into depth a bit later. And this is similar to how you might share something on GitHub or share a code repository on GitHub. On the Trophy service, this is also where you can browse and try out experiments from other users that have been uploaded. And finally, I'll also mention we have a feature called Chameleon Day Pass, which is a way for you to give access to your artifacts and let other users run your experiment without them having to go and set up their own project and allocation to do so. So all that's to say is Chameleon is extremely versatile, which is why we've been able to support so many researchers and educators over the 9 years or so that we've been in operation. With close to 700 publications, over 1,100 active projects on the platform, from almost 10,000 users across the globe from a huge variety of institutions. So as I mentioned before, Chameleon sites have a wide variety of hardware, storage, networking capabilities. We have various CPU, GPU nodes, even FPGA configurations, and you can reserve any of these resources and use multiple of these resources at any given time. Using this hardware, our users have conducted a tremendous variety of experiments, such as autonomous vehicle control and improving power consumption for deep neural network training, to name just a few. If you want to learn more about these projects or anything else going on with Chameleon, you can check out our blog at chameleoncloud.org/blog, where we publish tips and tricks to help users run their experiments smoothly. And we also feature blogs from our users to update the community on the latest research coming out of the testbed. So now that you're hopefully excited about Chameleon, let's go ahead and get into some of the topics that Mark will be demoing in depth today. So to start, let's go over a little bit of basic terminology. Here are some important terms that you want to know when getting started with Chameleon. The first one is the project. Your project is where all information about your work lives. Projects have members, they have resources, they have publications, etc. And projects are user submitted and user directed. So we do review projects on our platform to make sure that they're a good fit for our platform, but your project is really yours to do with as you wish. To begin working with Chameleon, each project requires what we call an allocation. You can think of an allocation sort of like a grant of computing resources that we provide to each project. So each project is given a finite amount of compute to use for your project on the testbed. And I believe in this case, Sasha has set up a project for the evaluation stage. On that project, you should be given an allocation of SUs to use per user. So you'll have a kind of a limitation to how many resources you can use through that project. And then finally, we have what we call the PI. So in this case, Sasha would be the PI of the SC evaluation project. The PIs are basically the project administrators and overseers. Lots of people can be members of a project, but each project only has one single PI. And in order to be a PI, you have to apply through the website. There's a special application that we provide for folks who want to apply for a PI status. Once your application is accepted, then you're able to create projects on the platform. So now we've gotten some of the jargon out of the way. Let's talk a little bit about what experimenting on Chameleon looks like. So on this slide, I'm showing what a typical experimental workflow might look like on Chameleon. It's very iterative. We'll be going over all of these steps in detail with the demonstration, but I'll be providing a high-level overview of this workflow to begin. So the first step, typically to determine for experimenting on Chameleon, is to determine what resources you want to use for your experiment. And this is what we call resource discovery. We provide some tools to help make this process easier for researchers. The most important tool that we have available for this resource discovery is our hardware discovery catalog. This catalog can be accessed on the website at chameleoncloud.org/hardware. And this is where you'll find different types of hardware across different Chameleon sites. The catalog lets you filter the available nodes on hardware specs, including the platform type, number of CPUs, threads, RAM size, storage capacity, and other hardware specs. If there is a specific node that you want, such as a GPU, or if you're performing experiments that require resources being in the same physical location, such as on the same rack, then you can filter for that through the resource hardware discovery catalog. And the nodes you can reserve are categorized by code names, which generally describe what the hardware is. But you can click on a specific node to get more details about exactly what it contains. So now that we know what kind of resource we want to use, the second step is going to be reserving resources. You can reserve resources either on demand to start immediately or in advance. We do impose a 7-day limit on all leases so that we can ensure that all users are able to access the resources fairly, but you are able to renew your reservation as many times as you need, so long as nobody else's reservation is blocking it. And when your reservation runs out, your experiment environment will be automatically torn down. And this is important because it means that when you're using the resources you've reserved and they're going to expire, you need to make sure that you take steps to back up what you've been working on the node. The reservation process begins with creating a lease for the resources that you want to use. Your active and future leases will show up in your dashboard, and this is where you can also create new leases. And I'm just showing the lease page here on the Chameleon website. Creating a lease is as easy as filling out a form. So each section of this form you'll need to fill in is highlighted in a different color here on the slide. The most important components of a lease include picking your lease start date and your desired duration for the lease, again, subject to that 7-day limitation. You'll also need to be selecting the number and types of nodes you want to include in your lease. The form also includes a way to filter for nodes and resources based on their properties, so you don't have to go back and forth between the hardware discovery resource, etc. And this is also where you'll be able to select the number of floating IPs to enable network connectivity. If you do want to reserve something that's in high demand, we strongly recommend doing it in advance because nodes can get very busy, especially during particular times of the year. And you can check node availability using our host calendar. This is where you can see which specific nodes are reserved and for how long. And this can help you plan when you want a reservation to start and see if the node that you want is available. You can also see the different types of resources that are available at each site in this way by looking at the host calendar as well. So after you've reserved a node, the third step is going to be to configure and interact. And again, Mark's going to be going over all of this in much greater detail. So if I'm going too fast or you're like, wait, what's going on? Don't worry, we'll be going through this in a much slower, more detailed, methodical way. But essentially in this step, you'll be deciding which image to use on your node. You'll be assigning a public IP and also, among other things, creating an SSH key pair to access your instance securely. And if you can't decide which image to start from, we do offer an appliance catalog with images that are all pre-made setups for experiments. Some of these images are maintained by Chameleon staff. So these ones that have the Chameleon logo, these are the Chameleon supported images, and these tend to be a little bit more stable. We maintain these images ourselves. There are also other images that you can see from other users that have uploaded them and shared them. And when you're done, if you've created your own custom image, you can also upload it here to share it with other users as well. So at this point, you've reserved your resources, you've configured and accessed them, you're ready to start experimenting. We also offer tools that allow you to monitor your experiment while it runs, which again will be further covered later in the tutorial. And after you've finished your experiment, you're ready to share it with the world. This is where the Trovy service comes in. This is where on Trovy you can package and share your experiments with others. And you can think of Trovy as essentially being an artifact repository, kind of similar to how GitHub is a code repository. Each artifact on Trovy includes the title, description, author, and descriptive tags to explain what the artifact is. And Trovy artifacts also support versioning, so you can update your experiments safely and revert to previous versions if you want to. We also include metrics on your artifact usage. And these metrics tell you, for instance, how many people have viewed your artifact, how many have launched it, and how many have actually run at least one component of it. We also offer some pre-made artifacts, which you may find useful for getting started. These are usually called tutorials or experimental patterns on Trovy, and they're basically demo experiments that you can copy and paste to fit into your own workflow. And Mark will be going through one of these artifacts today during the demonstration. So if you'd like more practice navigating around Chameleon or are interested in exploring different types of experiments that are possible on a Chameleon, Trovy is a very excellent resource to do so. And then, of course, last but not least is what do you do when you get stuck and you need help? So we offer a variety of support materials and resources. Our first recommendation is always to go and check out our documentation. We have a read the docs site that's very thorough. It includes a lot of the information that you'll need to use Chameleon effectively. There's also a FAQ, which is linked on our website, which has more information about common questions on how to use Chameleon. It also is where we put a lot of our testbed policies, such as what's required for PI eligibility and things like that. And then finally, we also have a staffed help desk where you can ask specific questions, or if you can't find something in the documentation or just something is going wrong and you don't know what to do, you can always reach out to us directly at the help desk, and we have people who will respond to you in a timely manner. And here are just the links to these resources that I just mentioned, with the exception of the help desk. Oh, I should also say we do have the blog, which I mentioned earlier, and the blog also does include a lot of helpful materials as well. So I recommend checking out that resource as well when you're getting started with Chameleon. And so that's going to conclude my portion here. I'm going to hand it over to Mark Powers to go through a lot of this stuff in more detail.
All right, thank you, Mark. Let me present my screen. So I'd like to give a bit more of a tutorial and a demo of our resources. And if you want to follow along, I've created this project that you can join. I just sent the link in chat. I don't know if you can see it, but if you can't, you can go to bit.ly/chameleon-tutorial-project. Or if you're watching the recording, we will expire this project in a few days. But if you want to get started today or tomorrow, you could use this project for that. And then once you go there, if you aren't signed into Chameleon, you should be able to click sign in via federated login and pick from your institution, or if you have a Google account or Orchid or a Globus ID, you can use all of that. After you sign in, you'll see a screen that says requesting to join project, and click confirm, and that will send us a request, and Mark will approve it as I'm talking here, and you'll be able to access the stuff I'm talking about. So I hear my email that a few people are requesting to join, so that's good. But maybe I can get started talking about the interesting stuff. Please send a Q&A if anyone's having difficulty, and I think Mark will be able to help out. Okay, so the first thing I wanted to talk about is kind of going through those steps Mark was talking about, actually using them. And we'll share these slides, but I have links here to specific documentation sections on that read the docs page that Mark was talking about, if you want to read more about anything. So I wanted to go through the graphical user interface, or the GUI, or the web dashboard, and just kind of show how you might get started with your first time running something on Chameleon. And Mark described earlier, the first thing you probably want to do is discover resources. And if I go to this link here, there's a hardware catalog, or maybe another way to get to it is if you're on our website, chameleoncloud.org, which you probably are if you just requested to join the project. You can go to experiment here, and the first link is called hardware discovery. So I'll open that up. And what this is doing is it'll show all of the hardware across all of our sites. So Chameleon has 6 sites here, though actually it only has 5. IIT is under development at the moment, but Chi at TAC and Chi at UC are our main 2 sites, and they have hundreds of nodes. Northwestern has only a few nodes, but they have higher bandwidth NICs on the nodes. NCAR has a lot of nodes as well. I think they have either 20 or 40, I'm forgetting. And EVL has some nodes as well. And if you scroll down here, you can see more detail about what a node is. Mark mentioned that these are bare metal. So these are, when you request one of these nodes, it's like having one of these computers, in your lab or something, where you have exclusive access to it and all of the resources that it's configured with. So let me choose nodes. I can filter by how many CPUs or threads they have. Let's say I care about GPUs. That's something that's very popular right now. I can click under these advanced filters. I can say, find me something with a GPU. And that's what I mainly want. So I'll click view. And if I scroll down, I'll see there's tons of nodes. Here's one, for example, the name is C11-21, and the type is GPU P100. And if I click on this, I think it will tell me that this is at TAC. I see it's in the URL at the very least. Yeah, oh, it does say site TAC, very first thing. Okay. So if I wanted to reserve this, I could look for P100 nodes at TAC. And you can also see, very specifically what type of processor it has, what type of storage devices this has. So depending on your research, those might be things you care about. Let me go back to that hardware discovery. So when you go to actually use one of these resources on Chameleon, there's two ways to think about it. If you just want something that fits a general category, that's what all of these different node types are. Like I just showed off a P100. But we also have things like Compute Skylake, which are a little more general purpose nodes that have Skylake processors. So I can view them, and if I go to use one, I could either just note the name, I could note just the category, or I could, use a specific ID. All of those might be how I query for the resource I want. Okay. So after I have, looked at what nodes there are and picked it out, I want to go to a site to actually start using it. And I'll pick Chi at TAC because that was the node I was looking at. So under this experiment tab, there's sites all here at the bottom. And it takes me to this overview page. You should see at the top, if you're in multiple projects, you can choose between them here, and you can also switch between sites. I would like to note that our sites are pretty independent. So if you have instances at one site, you won't see them if you're on the wrong dashboard here. But now that I'm at Chi at TAC, I can go to this reservations tab and then click on leases. And it says there's no leases that have been made. Let me zoom in a little bit in case it's small. But I can create one with this button. Or first, let me click on the calendar. And I opened that in a new tab. So it'll take a second to load. So this is going to show the availability of these nodes. So I was looking at a P100 node in the hardware calendar. Let me search by P100. And what this is showing is there's a row for every node in TAC. And it's showing horizontally the time that that node is reserved. So I can see here, this first node is reserved by somebody until May 1st at 22:29. And if I scroll down, I see there's one P100 that is available right now because there's no reservation currently active on it. If I go to another node type like Skylake, you might see these are pretty busy. And here's one that looks like it's in the future. It hasn't started yet. And let me go to like let's see something. So one thing you may have to do when using resources on Chameleon is reserve them ahead of time. I don't see too many at the moment that are in advance, but if you want a node for a few days to iterate on your experiment, you may need to create the reservation ahead of time and wait for it to start. Or for example, if I wanted Cascade Lake nodes and I wanted 5 of them, you can see that there's no time right now where there's 5 of them available. So it looks like I would have to start it out here on the 29th, perhaps. So that is the calendar. And if I go back to the leases page, I can create a lease. and I'll name it something like Mark's demo lease. And I'm going to just create one for one day, and let me reserve a host called which one was available? I think there was a P100 available. And let me go back. It looks like I did fill out everything. So I'm also going to reserve a floating IP for this node. And let me just get that started while I explain it. So as Mark mentioned, because our resources on Chameleon are shared and there's a limited number of resources, like you saw, there's very high usage at the moment. Because of that, we enforce people to make leases on the resources before they use them often. And you have to do that for all bare metal nodes. And you can also do it for IPs and isolated networks, since all of those are limited resources. So I didn't have to necessarily reserve a floating IP, but it's a good idea to do one if you want to guarantee there's one for your experiment. So I click on my lease now, and it used to be pending, but now it's active because I waited a second. And I can look specifically at what I got. So if I scroll down here, it says the node I got is C11-20. And when it made the lease, all it did was filter by nodes of type GPU P100. So I have these resources available now. If I want to go use them, I can go under the Compute tab. And if I go to Instances, there's a Launch button. And I'll create an instance. I'll say this is Mark's demo instance. And I pick that reservation. And then if I go on to the next tab, I can pick the image I want to boot. So there's a lot of images here, especially because our users can share their images publicly. But one thing I'd recommend is to sort by this Chameleon supported tab, and this will show the images that we make, and these are the most common images to use. So I'm going to choose this Ubuntu CUDA image. Since I got a node with a GPU, I probably want to use the image that has CUDA on it. Depending on your experiment, you might have different requirements for CUDA, depending on what version you need to use. So you might want to just use the base Ubuntu and install CUDA yourself. But this can be a bit of a convenience. So after I pick that, I'll need to go to the next tab and select what network I want this to run on. And I'll just pick shared net, which is the default network for instances on Chameleon. You shouldn't have to provide any network ports unless you have specific requirements. So I'll move on to key pair. And here you'll want to pick an SSH key in order to connect to your instance. So if it's your first time using Chameleon, you might want to click create a key pair or click the import button to upload a file. I have used Chameleon before, so I'll pick my SSH key, which I named Mark. And then I'll click launch, and my image, my instance, you can see is now building. Now, this is a bit of a downside of our bare metal sites, is that because we're provisioning a node for you, that requires us to download the image onto the disk of that node and flash it and boot it. And it also it takes a bit of time to configure the networking. So this process might take between 8 and 15 minutes, depending on the node type you have. So if I click on this, I can see it's less than a minute old and it's still going to build. So maybe while that happens, I can talk about other things on Chameleon. So let me go back to our hardware browser here. Some other tabs we have that might be of interest is the appliance tab. And here we also show all of those images like Ubuntu 22. So I just launched the Ubuntu 22, and there's a bit more of a description here of what exactly is going to be on that image. And we also talk about how we build this image, if you're interested. Another thing our appliances do is there's also some orchestration similar to Terraform, where you can declaratively say what your node should look like. And let me sort by that. I think a good example would be our NFS node. So this is an example of that template where it will provision an instance for me and set up an NFS server and clients with it. And I think if I click on this template, yeah, you can see how this is done exactly. It's a bit of an advanced topic, but we have documentation on it if you want to learn more. And I think it's going to take a little longer than we have in order for this image to build. So I did prepare one ahead of time on UC actually. So yeah, here I switched to the UC site and I have a different instance that I made. You can see the age is an hour ago, but let me switch back to my demo. There's one more step I didn't do, and that's I should be able to do it while it's spawning. I reserved a floating IP. So if under the network tab, there's a floating IP section, and I can see I got a floating IP object to show up here. I will click associate and say to associate that to my demo instance. And that mapping is now in place. So my instance is still going to build for a little while longer, but I'll switch in for my test instance from this morning, which is pretty similar, though this one isn't a CUDA image since there were no GPU nodes available at the time. Let me switch my screen share. Okay, I think you can now see my SSH, my terminal. Let me zoom in a bit. Okay, so once 10 or 15 minutes has passed and your image stops building, you'll see something like status active. And what that means is I should be able to take my IP address, which is down here in the IP address section, and I can open my terminal and I can SSH the IP. I tested this morning, so you might have to accept the key for the host since it's an unknown host. But I got into this instance here. I can do ls CPU, I think. Yeah, and I'll see this is a CPU with, what does it say? Yeah, 96 threads. So this is one of our Cascade Lake nodes that has some very powerful CPUs. But this doesn't have any GPU or anything that special. If I do ls, I can see there's some information already put into this image. And this is one of our customizations that we do. So if I open up that README, it talks about mounting point, which is an object store that we mount into your node. So if I ls that, I see there are a few buckets. And I can also see that under our object store tab here. And I think if I do ls as well, there's also this OpenRC, which is just your OpenStack credentials. So in case I wanted to run any more cloud commands, I could do it from inside this node. I think I'm getting a bit ahead of myself with that. So let me stop for a second and ask, were there any questions about this so far? So I've walked through the basics of what does it look like to provision a resource in Chameleon. Okay. So another thing that you might be interested in, other than just our nodes, I mentioned you typically pick this shared net when you launch an instance. Other things you could do is you could set up an isolated network for your nodes if you wanted to monitor the traffic between them. If you have an experiment that requires that, or experiment that requires certain isolation of your traffic. We also have this FabNet, which is a way that you could stitch nodes between sites. I don't think I explicitly said it, but I've been using the TAC site and the UC site. UC is located at Argonne National Lab in Chicago, Illinois, and then TAC is located at the Texas Advanced Computing Center, which is in Austin, Texas. So if I want my nodes to talk to each other on easily on a high bandwidth connection, this FabNet is utilizing a testbed called Fabric to manage that connection. And we have some examples of it that I can point you to later. But Fabric is also a good way if you want to configure your network with very specific parameters, like adding in latency. That might be something of interest. I mentioned we have these appliance templates. This is what the orchestration tab is used for. You can launch one of those templates and it'll do some automatic parameters for you. And then I was just talking about the object store. So if you've used AWS S3 or Google Cloud Storage, we have a similar object store interface. And this allows you to create containers, like I created this test one, and you can put files in there as objects. And we have in our images this Fuse program that's running to mount it into your home directory. But you also could configure this to use the S3 CLI or rclone. The APIs should be compatible with that. And then our next tab here is our share system. So if objects and mounting the object store is insufficient for your storage needs, we also provide a network file system that your nodes can connect to, and you can store experiment data there. And that's what this shares tab is for. And I'll point you to the examples we have for that later. And then lastly, our reservation tab is what we use to make leases. So the lease I made earlier, I think was this tutorial demo one. There's one more thing I wanted to say while I have this shell open, is that since this is bare metal, I not only can do whatever I want with this node, but I have root, so I should be able to run sudo and install whatever software you need. As a lot of experiments, I'm sure you need to install custom software for. We do, of course, have a code of conduct. So if you're doing anything that isn't polite or might affect other researchers using the platform, you shouldn't be doing that on Chameleon, and maybe we can work out a way to mitigate any impact you would have on other researchers, or we can also work with you to sandbox your research potentially. So, for example, if you're doing security research where you're listening for malicious traffic, we have some users who've done stuff like that. But something like that, please let us know first, because it looks very suspicious to us when we're operating the testbed. Yes, another thing I want to say here is because our nodes are bare metal, we don't actually have security groups, which you might have used if you've used AWS before. Instead, we set up, I think, firewall D. Yeah, I'm not familiar with the command. We used to use UFW, and then we recently just switched to firewall D due to some upgrades. But we have documentation on configuring this firewall if you need to open custom ports on your node. Okay. Yes, and then I also have a note here on CC snapshot. So I pointed out if you have data, so when we started this instance, we had to make a lease first, which we showed how to do. And for that lease, I gave it 1 day of length. And you're probably wondering what happens when that day is over. Well, your lease gets deleted, and any resources that lease is for also get deleted. And if you're running an experiment on a node and your time is up, it'll delete your instance and you won't be able to access it again. So in order to prevent issues with that, we recommend using tools like Git to back up your experiment program, or using our object share to store your data files on, and that NFS share system to keep any data you need permanent off of your node in the long term. If you do want to make a custom image with maybe your program dependencies installed, we have this CC snapshot tool. So I think I can do help. Let me see. So this is a program we've made that lets you snapshot your running instance. And that means anything I've installed, any program files, will automatically be there next time I go to use it. And that's what a lot of these images were that we saw when I was launching my instance. These are from people snapshotting their image and then making it public so other people can use it. Okay. So I think I have talked about everything Mark hinted at in the first section of this tutorial. I'd like to move on to some of our other interfaces and how to use them. So in order to show off our next interface, I have this slide here, though you don't have the slides at the moment. So let me go back to our website and show you how to get there. If you go to experiment and then down to Trovy here, you'll be taken to our artifact repository. And this is where you can share things that will automatically launch on the testbed. So if I search for bare metal, I see this second featured artifact, bare metal experiment pattern. If you click on it, and then you should be able to click launch if you're a part of a Chameleon project. Once you do that, it will load a tab for you into a Jupyter Lab interface. So if you're unfamiliar with Jupyter Lab, I'll show a bit about why we provide this, but it's kind of a virtual workspace for you to do your experiment in, and it saves your work, and it is authenticated as you to the testbed. And it also lets you share your files. And these are some advantages that we think it has when you're trying to run an experiment. So I just showed all of this GUI stuff, and a lot of programmers, they don't really like having to click a bunch of buttons and remember all of the options. So this is why in this Jupyter interface, we can share a file like in this bare metal experiment pattern folder. And if I open up the README, it will describe a bit about this bare metal experiment template. And I can go through it here, but essentially this is teaching me about Chameleon, and that this is going to show you how to run Chameleon inside a Jupyter notebook. And there's different steps. So in this experiment.ipynb file, it'll create a reservation, create an instance, and install stuff on that instance, which gets us to the same point that we just got to using the GUI. And then this one goes a bit further and actually creates an experiment and runs it and does some analysis to plot data. So if you've never used Jupyter before, essentially all you have to do is click on a section of code, and then you can click the run button. And if I do that, I see it prints out the current time. So let me open up that experiment file, and I can walk you through all of the same steps that we just did, but in Jupyter form. So this experiment file is a power management experiment, which will run a program in order to measure the power used of a node using some fancy tools. So the first thing we have to do is configure, and in order to do that, you have to give it your project name. So let me do that. If I go back to my profile on chameleoncloud.org, and then if you go to projects, you will see a bunch, well, you will only see one project. I am a member of too many at this point. If I search for the Chameleon tutorial project, it's this last one. Okay. I'll see the ID of it is CHI241306. I will go back into Jupyter. I'll paste that here, and I'll run the cell. Okay. And now I need to create a reservation. And this next section of code is some Python code that does what we did when we created a lease with the GUI. Now, I should go back and check the host calendar, since I think it's pretty full at this point. See, there's one node left. Let me delete my leases from earlier, actually, to free up some more. Sorry about how full our resources are. If you're following along, you might run into not enough host error due to there only being a few hosts available. But back into this Python code, I can read through it a bit, but I see that it has this lease node type variable. And if I go down, it gets a reservation for one floating IP and one node of that node type. and then actually creates a lease for it. So let me click run. It says creating lease. And now it has to wait for the lease to start. And to just show that this is doing the same thing that we did in the GUI, let me go into our project. And on the leases tab, I see my lease here that I just got made. And if I look, I think it'll tell me that this is giving me node P3 CPU 027, which since I think we have some time while this loads up, switch to the hardware discovery tab. And this was a Cascade Lake R at UC. Let me view. And I'm going to search for that node. Okay, here we go. So I can see precisely what I'm going to get when I boot up an instance with it. Okay. I'll switch back to Jupyter, and I see it now printed out that my lease is active. So everything went well. Now, the next step is this little bit of a longer step. It's going to provision that node, which is the same thing we did when we launched the server. So let me start that off here. And this time we're going to use CentOS 8, which you might be more familiar with over Ubuntu, depending on your experimental preferences or needs. So it created that. Let me switch back into the web dashboard, and I can see my image is there, or my instance is there. And this is going to take a little bit of time. So while that goes on, maybe I can also show you another advantage of Jupyter here. So
just real quickly, I think we have just a question that maybe can be answered quickly in the Q&A.
Okay, I see issues accessing TAC. This could be if you're on a VPN. You might want to contact your institution's IT. I know we have had issues where some universities don't allow you to connect to it. And I think that is because the APIs that the dashboard uses are not on standard web ports. Here under the API access, I think in particular, the identity API sometimes gets blocked from university IT websites. So if you could ask them to whitelist this, I think they should be able to help you out. Okay. Okay, I wanted to also show maybe a few more features of Jupyter here. So if you're a systems programmer, you might prefer the command line. And if you click plus here in Jupyter, you can launch a terminal here. And what this does is gives you a terminal fully authenticated with your Chameleon credentials. So if I do OpenStack help, I'll see there's a very long list of commands that you can use to access Chameleon. I'm going to search for reservation because that's the first step that we were talking about. And let's try this lease list command. So OpenStack reservation lease list. And it's taking a second, but this is showing all of the leases that I was using. And these look a little different than what I was demoing because this is actually using a different project at the moment, since I have quite a few. But if I look back up, there's OpenStack commands for everything that we've been doing in the dashboard. So if I do OpenStack reservation lease create, and let me try help, this will print out some documentation on how to use it. And if you want, this documentation can be a little difficult to understand. So let me go back to our Chameleon website. Under the About, under the Learn tab, our documentation, we have a guide on using the CLI. And in Jupyter, you don't have to worry about installing or authentication. You can skip down to this using step. And then we have topics on the individual parts of the CLI. So if under reservations, I can click on provisioning and managing resources using the CLI. And this shows me command examples on how to do everything we just did. For example, here's the command to reserve a compute Skylake node from this date to this date. So one thing that I think some researchers I've seen do is they prefer to use the CLI, use our examples. So first, they create a lease, and then they'd switch to this bare metal instances tab, which shows you how to create the server from the lease in the CLI. You could run all of those commands here in your Jupyter terminal. But another power that Jupyter has is you can save all of your commands into a notebook here. So let me copy that command from earlier. So I can copy it and run it. And the notebook format will, save my code, which in this case is Bash instead of Python. And it'll save my output and I can iterate on it. And if I wanted to share this, it might be helpful to switch this from code to Markdown and say, here is an example of listing all leases. And I can run that and just add some explanatory text to my program here. And this is, if you're familiar with literate programming, this is letting me, annotate all of my commands and still keep it very easy to run everything for the next user who wants to come along and repeat what I did. So I think some people do prefer the commands, but here in our Jupyter example that I think is still pending, we at Chameleon have built on top of those commands a Python interface, which can be a little easier to navigate in terms of managing errors or customizing different configuration properties, like changing how many nodes you want or using different APIs to combine information into your requests. And I think we'll have in our read the docs a section here on our Jupyter interface that talks a bit about what I'm doing here. But I think I don't actually see the link, but our interface is called Python Chi. And if I search Python Chi Chameleon docs, let me see. Yes, this first link, we have a separate read the docs for this Python library. And let me add that into my slides so when we show them. And this shows all of those Python functions we were running already, like add node reservation. We used to get a Cascade Lake R node. And if I go onto chi.server, this has a create server command with a bunch of the stuff we just used as well. So Another bit of context as well, I think okay, it looks like my server did start. So I can go on to the next step maybe, which will add the floating IP and wait to make sure it's active. I think that may take a few seconds so I'll talk about the context. So Mark mentioned at the beginning of this webinar that Chameleon is built on OpenStack. So OpenStack is some software that is running clouds. And if you've used different clouds before, you might have seen a similar dashboard if they were also using OpenStack. And we have extended OpenStack's services in order to provide bare metal access and meet researcher needs. And for example, the reservations we've extended a bit to work with Chameleon resources like bare metal nodes. And if you're using their command line interface, like I was showing here, you might see some information that isn't the most relevant to Chameleon. So this is why it might be most useful to use our Chameleon docs in order to get started. But there are some topics in which we haven't built on top of. So if I go to KVM, for example, since researchers want virtual machines, and OpenStack also provides virtual machines, we have this KVM site. And my apologies, I think I'm switching tabs too fast. And on our docs, we have a link here to KVM, which we've set aside some of the nodes at TAC only for running VMs. And here, you'll be able to spawn VM instances, which are much smaller and less powerful than bare metal. But depending on your needs, as I said, they might be fine for those. And here I could launch an instance and I don't need to make a reservation. We don't enforce that for virtual machines. But it's slightly different than what you saw with bare metal. So I can go through and add my instance name and select, let's say I want to pick Ubuntu. And I need to pick image first. But I can search for Ubuntu 22. Again, since this is VMs, not bare metal, I need to pick what size of VM. Like I'll just pick tiny. And I can also pick shared net once again. But you'll see this tab, there's many more options for VMs than there is for bare metal. So I mentioned bare metal doesn't have security groups. We still do on KVM. So if I want to SSH, I'll need to pick allow SSH. I will add my key pair. And I can also do further configuration, like adding a script to run on boot. And these last few steps I think are fairly uncommon, so I will just ignore them, go to launch instance. And this tells me my flavor disk is too small. I forgot about that. So let me pick the next size up, small. Okay. I think it will take a second, but now we see I've created this instance and it's building. And from this point on, it looks very similar to a bare metal instance, except when I go to SSH to it, I won't have a node standalone just for me. I'll be sharing a hypervisor with other people. But I guess just for the sake of seeing it through, let me create an IP, and we have some extra ones in this project. And assign that to my KVM demo instance. And let me go back to instances. Okay, and just like before, I can take that IP. Oops. Sorry, let me open a new terminal. Uh-oh. Okay. I can do SSH CC at the IP. I'll accept the key. And now I'm on a different node. If I do ls CPU again, I should see this time I only have one CPU thread. But there is some advantage here, not having to make a reservation if you want to play around with things now and maybe move it to bare metal in the future. Okay. Let me get back into Jupyter and this experiment tab. So I see it says connection successful. So it took a little bit in order for the networking to be reconfigured, but my Jupyter notebook was able to connect to my bare metal node. And to prove it, I'll stay in Jupyter. One of the advantages of Jupyter is it has this terminal. And let me actually do this picture-in-picture view. So I can test things out myself by doing cc at that IP. I'll accept the key. And I see we're in. I can do ls, and it looks like my previous bare metal instance with the mounting point. Let me do ls CPU for fun one more time. And yeah, now we're back on a nice 96 thread CPU. Okay. So I'll close my terminal. So these first 4 steps here have shown what we did in the GUI setup stage, but in this programmatic step of Jupyter. And now I'll go through and actually run this demo experiment to show how you might set up your experiment. So once you have SSH access, as I mentioned before, you can kind of do anything you want. I'll run this cell to get it started, but this connects to my floating IP over SSH and runs some remote commands on it. And I can open what those commands are. They're hidden inside the setup script. So this installs my stressng package onto the system using DNF, which is the CentOS package manager. And I think that's going to take a little bit of time to update everything. So once that is done, I have another script I'm going to actually use to run the interesting metric. And it's going to use that stressng program, and it's going to combine it with this etrace program. And I'll check the etrace is monitoring the power usage of the CPU. And I'm going to check the power usage of stressng running on a quarter of the cores, 50% of the cores, and 100% of the cores. So this is just a bit of a demo, but what I would expect on this node is that as you're using more CPU cores, the power usage is going to be higher. So let me switch back to my experiment. It says it's complete. Now let me upload and run this experiment file. So running at 25%, 50. After this, we'll just download the results and extract them here into Jupyter. And we've been saving the results as we've done this demo over the years. So I can actually see the previous trials. which might be interesting to analyze. Since we're using the bare metal nodes every time, I expect, to have pretty consistent results. Okay, so it says that finished. Let me run. And if I go to out, I think I should see, yeah, I have seconds ago, it created these new trace files. So let me go back up into my experiment pattern. The other notebook that I didn't talk about packaged with this is this analysis notebook, which just lets me view all of that data, and Jupyter lets you show images and graphs directly inside of it. So looking at this, I think I am seeing kind of interesting data here that, for 25%, it was using about 260 watts of power. And we see there's a bit of a ramp up over time as the experiment was running. But for 50 and 100% of power, we see that it's fairly close together at, maybe 350 and 320 respectively. So this is maybe not the most interesting experiment, but if you wanted to run an experiment on a single bare metal node on Chameleon, you could take this as a starter template and replace the experiment files here, the experiment scripts, and also the experiment setup script that I showed off. And of course, your analysis might be completely different. But the main idea is getting you to the point where you can configure your instances. Okay. So I think I have talked about most of these parts of the experiment orchestration. And I wanted to finish up this first half of the tutorial with some best practices and tips. So you saw I was making reservations, and one best practice for those is checking the availability calendar to see what resources are available, but also to limit the length of your reservation to only what you'll need. If you make a list that's too long, you can always delete it early, just as a courtesy to our other researchers, especially as many people are trying to use this, especially this week as it's near the end of semesters. There's always a bit of an uptick in usage. Also, I talked about uploading your data so that you don't lose anything once your lease ends. And I link to our object store and file system documentation here. And then just for help, Mark already talked about this, but there's the documentation. There's our blog, which if you're on chameleoncloud.org, there's a button on the top right. And here we highlight a lot of user research, and that will let you see what is possible with Chameleon, maybe give you some ideas. And we also have tips and tricks where we write blog posts about how to use Chameleon services. Let me actually show off one. Like our most recent tips and tricks here is about Chiat Edge, which I didn't talk about, but if you're interested in running container workloads on edge devices like Raspberry Pis or Jetson Nanos, you could read more about that in this blog post, but we don't have time today. And then lastly, a very helpful resource is our help desk. So anywhere on our website, I think you should see a help desk button at the top, and there's also one at the bottom. And as Mark mentioned, we have staff ready to answer your questions. So now I wanted to pause at this step in order to see if there's any questions. And next I was going to talk about specifically our tools for reproducibility. Okay. All right. If not, I think I will go ahead and get started. If I present this, I think you should still be able to see it. Okay. So let me actually go here. So I was kind of getting into a bit of a problem that researchers might have managing all these different parts of their experiment as I was managing it in the demo. You know, I'll have some code that is my experiment, and I'll have my environment that is on the node that contains, you know, maybe CUDA and Ubuntu. There's all the resources in the cloud on Chameleon. And then you also have some analysis of your data that you want to do as well. And this is why we offered Jupyter as this glue to kind of combine all of these different parts together. So when you log into Jupyter, you can you can set up your experiment, you can orchestrate your experiment using those remote commands on Chameleon, and you can also use the same environment to generate some analysis that you could use in a paper. So that's one of the benefits of Jupyter here. And also for reproducibility, this Jupyter environment gives everybody the same environment in order when they're running your code. Everybody is assigned into the same Jupyter lab environment, so you don't have to worry about what version of Python they have installed, or did they set up their authentication credentials correctly. So specifically, in order to address reproducibility concerns, Jupyter is kind of a starter, but in order to make it easier for authors and users, we have some more points that we address. And the first of these is the author wishes to share their experiment in some sort of package that's nice to a user, but also is cost effective for the author. And on the other hand, once the user is using that package, they want to easily understand it and be able to tell what's going on. And that's where we think Jupyter also does well, as you can have literate programming and diagrams and explain the story of your experiment as a user is walking through your file. And again, I just mentioned it's integrated with Chameleon. So because you guys were on a Chameleon project, you'll be able to launch this Jupyter environment and provision resources in it. So I showed off this earlier. Maybe I can show it off again. But on a packaged Chameleon artifact in Trophy, there's this launch button that automatically will take those files and load them onto this Jupyter environment. And I think we saw some of this. It takes a second to load, but here are my files that I just worked with. The second point of reproducibility that we have tools for is actually being able to share your work and publish it. And then as a user, you want to be able to find someone else's work that's relevant to you. And I've been saying the word Trovi, I think, but more formally, Trovi is this API service that powers the Chameleon sharing portal. And this is an open source service that right now is integrated with Chameleon. And we're looking to extend this and improve it. But it allows us to launch an experiment and take you right into it. And here is a screenshot of that portal that you can search for artifacts in. and search by tags. And you can also see different types of artifacts. Some might be stored in GitHub. Sorry, let me actually walk through that here. So under experiment, there's Trophy I mentioned earlier. And I just went straight to the bare metal experiment, but we have quite a few featured artifacts here, which are high quality artifacts and good starting points, we think. Things that might be very interesting to you. I can search by tag. So for example, if I want to find reproducible research specifically, I can click on that tag, and this is showing me, research that goes with papers typically. And we also have this initiative Repeto, which shows different badges that we have confirmed are good. There's also a font badge here, which is the little hat, which is all about educational modules. Let me clear that filter. So one thing I think people at SC are very interested in is you might want MPI. So we have one MPI template here. I won't walk through it at the moment, but if you want to poke around this, you can read through it, and this does similar things to what I showed off earlier, where it launches instances and goes a step further to configure them into a cluster. Yeah. Now, the last step of access of reproducibility on Chameleon is this issue of access. We talked about it at the start, but you have to be on a Chameleon project in order to use Chameleon's resources and use Jupyter. So for this tutorial, we created a project for everybody here, but normally what you could do is you would be on a project for your research. And what we've set up is a way to give people a day pass, which will be a request that they make to you for a few hours on Chameleon. And that will let them join a project only for the time it takes to reproduce an experiment. So our vision is, someone is reading your paper, and here are those graphs we just saw. Someone's reading your paper and they're very excited about it. Maybe they want to, do their own analysis with your data. So they can click some link. It takes them to your artifact, and there'll be this big button, request day pass. And they do that, fill out a form. It gets sent to you, and then you can say, yes, this person is allowed, can use Chameleon for 2 hours in order to run my bare metal experiment here. And that reduces the barrier to getting the same resources that you used when you ran your experiment. So putting everyone in the same environment. So that's kind of at a glance what these different tools are. We had already started using the first part, launching an artifact. But now I was hoping to go through on how these artifacts are created. So I think if I were to create an artifact, the first thing I might do is actually launch this bare metal experiment pattern artifact. And actually, I think I might download the archive to my computer, because what I can do next is go to this button for the Jupyter interface, which will take me to like a persistent workstation that is not tied to that artifact. So this is like a bit of a scratch space, and you can use it in order to iterate on your experiments. I think you'll see here in mine, I have quite a few files through my time at Chameleon that I've been working on. But what I would do next is upload from my computer here that bare metal experiment pattern zip, and I can extract it. And I already have done that last time I did this demo into this file here. And I maybe want to rename it into Mark's demo experiment. And then I can go inside, I can take, these files, edit them so that they fit my experiment. And we talked about that probably means I want to go in to the setup, and instead of installing stress-ng, maybe I want to install some other package. I would do that, and maybe I don't even want to use DNF. I would instead want to do apt update -y, and then sudo apt install packages. Because I prefer Ubuntu over CentOS. And I could go through this notebook, make all of my changes. So like I mentioned, cc Ubuntu 22.04. And test it out in this environment. And I'll make sure it's all ready. I'll go into the analysis and edit this for my experiment, or maybe just replace it in entirety. And then once that is all done, I want to actually share it with people. So we have a few different tools to do that. The first will be here inside Jupyter. I can right-click on my folder and click Package as New Artifact. And I can give out some metadata. So I'll say this is Mark's demo artifact. And this is a demo showcasing how to package new artifacts for the SC24 tutorial. And I'll leave it as private right now, since I don't actually want people to look at this and be confused. I'll fill in my institution information, and I'll click upload. And your artifact was successfully packaged. Let me click on that link. And it says not found, but I think I have to log in. And then, okay, yeah, since my artifact is private, I had to just log in to see it. And here on the sharing portal, let me go back to the main page. I'll be able to see it here since I'm the owner, but it shows up right above that latest artifact somebody made. I have a few more options on this page. I can edit since I'm the owner, and I can say this is an example. Give it that tag. I can allow more people to edit my artifact under these roles. And we have some documentation on that as well. Or I could update the authors, and I'll save changes. Okay. And now if I click launch, I'll wait a second. I am concerned we're hammering our Jupyter hub a little hard at the moment, but okay, it looks good. Yeah. But I expect once this progress bar finishes to see my custom artifact files there. Okay. Okay. Yep, and I see Mark's demo experiment folder. And if I open up that setup file, I see, yeah, it's using app, like I said. And under the experiment, we'll see it's now using Ubuntu 22. Okay. So that's one way to make the artifact. I can also come along later and let's say I make more changes to this file, my experiment file. Now that I've uploaded it, I will be able to create a new artifact version, and it isn't letting me at the moment. Let me go in and create a new file called, like, let's imagine something changed. I think I'll be able to create a new version. Let me refresh, I think. Oh. Well, I will look into this issue, but I'm pretty sure it'll let me. Okay. So, yeah, now it lets me create a new artifact version. Just have to refresh. And I'll click upload. Okay, it says the new version was created. Let me switch back and refresh my Trophy page. And I can see here that there's two versions to pick from, and it'll pick the latest one by default. Another thing you might be interested in that Trophy has is we show metrics. So here you see we'll track how many people launch your artifact, how many people how many individual users clicked it, so removing out duplicates. And then how many users also executed some of a Jupyter notebook from within that artifact in our environment. So you can kind of track that. Another thing that you might be interested in is not everyone necessarily loves to edit files inside this Jupyter environment. I believe like you could use VS Code, which some people have extensions for syntax highlighting, and it might be a nicer development experience. So another way to create Trophy artifacts is if you go to GitHub. So I'll just go to Chameleon's GitHub, and I'll pick our Python Chi repository here, which is that Python library source code that I was talking about earlier. I can copy its URL to the clipboard, the clone URL. And back on the Trophy main page, I can import an artifact from Git. So I'll give a title. So I'll say this is Mark's Git artifact demo. And this is a demo on importing via Git. So showing how to import from Git. And I'll say this is just another example. And I'll fill in my affiliation. So first, oops, it didn't link my email address. Okay. Okay. All right, fix that form error. I'll add my remote, which is that clone URL. And next I have to pick what tag I want it to use for this artifact. So there's a bunch in here. So, it looks like 0.17.11 might be the latest. If I didn't use custom tags, I could also just use the git head, which will always clone it from the most recent commit in the default branch. I'll click submit. And oops, it looks like I have a typo. So I'll give an example. I can go here and edit that. This is an artifact on importing via Git, showing how to import from Git. Save. And updated. It made it private by default. Another thing on this edit page is I can import again from Git if I want to change the tag, for example. So let me launch to show this one. While that launches, I don't think I showed the sharing tab yet, but this is where I would turn it public with this checkbox. There also are private links if you just want to share with somebody before you make it public. But let's make it, I won't make it public just so to prevent any confusion. And then down here are the day pass settings, these last three. So the first thing you have to do for day pass is set what project this artifact is a part of. And I'll say this is a Chameleon tutorial project. And that's so we know who to ask when somebody requests a day pass on it. Excuse me. And then this reproducibility requests lets you, if you're getting too many requests or this artifact no longer can be supported, you can toggle it here. And you can also set how many hours somebody has to reproduce that artifact. So this is a demo, I'll just say 1. And if I click save, I updated the sharing settings, and on the right, there's now this request day pass button, which it describes a bit. If you don't have a Chameleon allocation or you just don't want to use your current one, you can request this day pass. So I'll click on that link and show you what that looks like. But basically, the idea is, somebody, you just want to see who else is interested in your research and make sure they're not going to abuse Chameleon's resources when you're granting them access. And this damage is limited a bit by the fact that they only have access to 1 hour. So if I go back to that launch screen, for my Git artifact, I should see that the animation is not very happy. Okay, here we go. But I see now it has this Python she file, and this is those contents from Git loaded into Jupyter. So you may prefer editing on Git and then just importing in Jupyter this way. But as I showed earlier, you kind of have a lot of power here in Jupyter with this terminal. I have Git as a command. So I could, clone, let me go into the work directory. I could clone any repository here in Jupyter, and I see it in the file explorer and package it from here as well. And the Jupyter also has this Git GUI if you prefer that over the terminal as well. Like here, I can see the history. I believe that comes to the end of what I had to show. But let me talk through maybe a bit more of best practices for creating these artifacts. So, so far, everything I've shown, the artifacts are all mostly code and documentation. There hasn't been any, I haven't bundled any libraries inside of it, and I haven't added any data sets into my artifacts. And typically that's for just best performance, since these Jupyter environments are not part of the high power Chameleon resources. And instead they're orchestrating those resources through SSH was the example I showed. So I'd like to recommend against including in your data sets, in your artifact data sets or disk images, and instead uploading those to like the Chameleon object store and downloading that directly onto your node instead. And if you'd like, let me go to the Chameleon documentation, which is chameleoncloud.org/read the docs. And we do have documentation on, how to use this object store, and you can get a link to your object and download it onto your experiment node. And I mentioned there's the CLI, and we also have an example on setting up the AWS CLI if you're more familiar with that. So some other best practices would be include some background into your artifacts so that people understand what's going on, and explain what method you're using. So relevant to Chameleon, I think that would include what resources are required or what assumptions you make. And that would be, saying this needs to be on any GPU node on Chameleon, and maybe pointing them to the different types of GPU nodes. Or say this must run on a node on the P100 node, because this requires a P100 GPU, and it won't work on an RTX node, for example. Other things that would be useful are to document any requirements that are outside, such as packages. This stuff can change over time, but we do try to preserve images for reproducibility. But for example, Ubuntu 14 no longer has package archives running. So if you don't have these mirrored, you won't be able to, somebody will have difficulty rerunning your experiment if it's older like that. But that's also a case in which you could use our CC snapshot tool to launch Ubuntu, install the packages, snapshot it, and that way those installation things are preserved. Another thing is to manage the expectations, and in particular, if something is going to take a bit of time, if you're running a machine learning experiment, maybe it takes several hours for something to run. Or I saw recently somebody had an experiment that took like 6 days to train their model. Something like that, clearly the user is going to have to come back to. They're not going to be able to run it in one sitting. And it also is helpful to tell the user what the stopping conditions are. How do they know that it works? Try to inform them of that. And then if possible, you might want to avoid any automatic output or noise from scripts. Like our examples aren't necessarily the best at this, but when I installed the ng stress package, and I think I closed that tab, it prints out a lot of DNF setup, which might be confusing to somebody who isn't familiar with it. So on this last slide here, I also wanted to point out there's a lot of experiment patterns which you might be interested in. I didn't have time to get into all of them. So we have a similar example for just a GPU node and installing CUDA on it. We have an example on using Chiat-Edge for the first time. If your experiment requires any specific networking, we have this networking tutorial. I mentioned there's a KVM one as well. I launched that. We have quite a bit of storage artifacts if you're interested in low-level storage research that requires bare metal access, for example. We have this one user who has connected Chameleon's resources into Colab. If you're unfamiliar, this is Google's Jupyter environment, but it lets you set the backend to something like Chameleon instead of Google Cloud, which might be more accessible to everybody. And then I mentioned as well, there's also like the MPI cluster, and there's another recent cluster for another recent Kubernetes cluster artifact that somebody made last week, if you're interested in that. And there's more examples on how to use our services, like I mentioned, the network shared file system. If you want to check that out, that will walk you through it. And a lot of stuff is on our documentation that I haven't had time to get into today. So that ends my demo. I know it's a lot of information, but yeah, I think Mark, I'm available for any questions right now, I think is the plan. And I'd be happy to, help.
Wonderful. Thank you so much, Mark, for that very thorough, excuse me, overview. We recognize like some of this may be a little overwhelming, so of course we'll share the slides, we'll share our video of the recording of the webinar today, so you have the ability to go back and rewatch sections or look more closely at some of the content on the slides. But I want to give some time for folks to ask questions. We should have probably about 10 minutes left or so to do so. So feel free to raise your hand. I can unmute you if you want to talk. You can also just put your questions in the chat. Sasha, go ahead.
Oh, thank you. Thank you for the introduction. That was good and very helpful. And there's a few things that I noticed, and I don't have answers to that. So when you store the images with the cc store command, is there any like limit per user on the amount of storage they can have?
So I believe the limit is quite generous at the moment, as it's stored into our object store, and we have plenty of space at UC and TAC for this. Let me double check if this shows. Like your project will have a quota, but I think it is, it hasn't been a problem yet on Chameleon, I'll say.
Okay, that's what I mean. When people, start, basically trying to share images, that somehow, when they have to be careful, like 5, 10, something like that.
So in terms of practicability of these images, we do find that large images won't yield great results in terms of actually booting them due to the boot process. And let me share my screen. We have this documentation I would recommend reading on CC Snapshot. It's under our images page, and I link it in the slides. But we say you may get warnings that the image is too large. But yeah, we have quite a few caveats. And I would recommend after you snapshot your image, if you could test it before trusting everything, just due to the nature of bare metal. The snapshot is not necessarily going to work. I think usually it works best if you snapshot right after, initially installing a package.
Can I ask one more?
Sure.
So the trophy thing is nice, especially for all the artifacts they would like to create. And are they deletable, these artifacts, or is it like on the node that once you create them, they can never disappear?
So you can delete them. You won't. One thing that I didn't show is there is a way to request a DOI, and once you do that, we don't let you delete that version. And we do that, we back it up to Zenodo in that case also, if you're familiar. But if you request a DOI, we don't let that version be public, or we don't let it be private, and you also can't delete it. But
All right, thank you.
Any other questions from our attendees? Going once, going twice. Don't be shy. Well, again, if you have any questions, I'm going to put my email in the chat along with Mark. And again, we will send out our slides, the recordings. You can also ask any questions that you may have through the help desk as well. That's also, it's probably the preferred way if you want to get actual kind of human contact. Again, our staff tries to respond to that within a reasonable time, usually, you know, within a couple of hours to a day. Sorry, I don't know if I should say that or not, but is that right?
Yeah, we typically promise about a day, and we actually
Okay.
read them. Like the entire team reads every ticket, so you'll get us. We'll see it. But yeah. Sasha, did you have another
Yeah, I
question?
just want to follow up on something that we discussed. I mean, some users that talk to me about Chameleon and these kind of things, they always have the question that, so how do they know, like you do a reservation in advance, maybe in 2 days or something in it, and well, it's kind of hard to like remember these kind of things. Do you get like information? Okay, you basically your time starts now, or are they notified? These kind of things. They always would like to know that.
Yes, you should get an email when your lease starts. Let me double check, but I have a bunch of lease started emails from my demo. Yes, you get an email. Actually, you might be right. You get an email when your lease is about to end, which will be when it starts if your lease is less than 2 days. So yes, I guess this is a little complicated. If you're making a short lease in advance, you will get an email when it starts. But other than that, you might want to make a calendar event. You're right. That's a good idea. I'll have to double check, but it looks like we might not send you an email when your lease starts. But I will add that at least to our list of features people want.
And I think you will get an email, I think 48 hours, is it, in advance?
Yes.
If you have a lease longer than that, so that you're reminded if you want to extend your lease, you can go in and extend it, because we restrict when you can extend your lease. So
yeah,
you can't just extend your lease immediately. If you once you get it, you have to wait. I think it's is it 48 hours or 24 hours before the expiration?
I thought it was 48. So yeah,
48.
I didn't mention explicitly, but you have up to you can make a lease for up to 7 days, and then once you get to the end of that lease, if nobody else has requested a lease after yours, you'll be able to extend it.
Just to be completely clear, so once your lease starts, your time ticks. I mean, basically you get accounted for that. So even if you forgot about the lease, you pay for that, right?
Yes, while you have a lease, even if you don't have an instance on it, it's charged to your project. If you run out of credits on your project, you can always request a recharge, and that'll probably go to Mark. And we'll examine your usage, and if it looks like you're not blatantly trying, just wasting our resources, we'll be nice, I think, most of the time. Yeah, a few hours idle. We will send you emails if your lease is idle, as in if it's been running for, I think, a few hours and there's no instance on it. So.
Oh, that is good. Okay. Maybe
Yeah,
even 10
I'm
minutes
forgetting
later.
I'm forgetting the timing, so I
Okay.
can't say, but
Yeah, I just
yeah.
have the feeling that this advanced reservation is kind of tricky to remember. You do something, okay, in 2 days from now, and then you forget, and then you get charged for the entire, like 7 days, and you have.
Yeah. I think if your lease is idle, we send you an email saying if you don't start using it within X hours, we'll delete your lease. So,
Oh, okay.
yep.
All right, well, we are now at the top of the hour. So thank you again to everyone who attended. Thank you, Mark, for that wonderful demo. Thank you, Sasha, for being here and asking some excellent questions. And I will be sending out the slides and the presentation video once it's ready to everyone's emails. So you should get that email from me within the next day or two. Thanks again for everyone for joining, and we wish you the best of success with your Chameleon experiments.
Thank you.
Take care.
Thank you. Thank you very much.